Alright, so we looked in the first video at how to integrate just some standard functions such as trig functions and exponential functions and natural ln functions. In this video we're going to be looking at the first of the integration rules, which is the reverse chain rule. For this particular method, it's all about trying to find patterns, and it's just experience, practice and just trying to see or just getting experience of these types of questions. So first things first, what you should be looking out for is a certain form of integration. So the form will be the integral of f prime of x multiplied by f of x raised to the power of n dx. So if I see a function raised to a certain power n, the n doesn't really matter for now, with its derivative multiplied together, then we know that we should be using the reverse chain rule. And if this is the case, our answer would be some k times the function raised to the power of n plus 1 plus c. Okay, so this might seem a bit confusing to you now, but we'll look at how to solve this. First things first, important things to note, this k cannot be a function. It has to be a number. If it's a function, then you know you went wrong, or it's not the reverse chain rule which you should be using. So if I were to look at a question, let's say I want to integrate cos x multiplied by sine x raised to the power of 2. Okay, we should know that this is a reverse chain rule because we have a function, the sine x in this case, along with the derivative. If I was to differentiate sine x, I get cos x, right? So we know that it's in the form of what we were looking for to use the reverse chain rule. After we've identified that, then we actually have to perform it. So what we do is we let y equal to the function and we add 1 to the power, n plus 1. So in our case, our function is sine x, and we add 1 to the power, so it's 2, so it's now going to be 3. We now differentiate it using the chain rule. That's why it's called the reverse chain rule. So it's going to be 3 times cos x multiplied by sine squared x, like this. After we've done that, we now compare our differentiated value along with the original integral. And we'll try and match them together, okay? So you can see that it doesn't have a 3, so I need to divide the whole thing or multiply it by 1 over 3. That means I multiply this one by 1 over 3 as well, because we want to make them the same, right? So our answer would be just the y value here, which is just sine cubed x over 3 plus c. So you can see it's in the general form, right? Because we've added 1 to the power and we found our k value, which is this 1 over 3 here. Okay, right, let's just try another one. So let's say I want to integrate sec 2 sec squared 3x tan to the power of 4 3x dx. We should know it's the reverse chain rule because our function would be tan 3x. If I was to differentiate tan 3x, I'll get a sec squared 3x, right? So it doesn't matter about the 2 for now. The important thing is that I will get a sec squared 2x, so 3x, sorry. So that's why we know it's going to be the reverse chain rule. Once you've identified that, then we say let y equal to the function with the power plus 1. So our function in this case was tan 3x. And we plus 1 to the power, so it's now going to be the power of 5. We then differentiate it using the chain rule. So we're going to have 5 and then 3 and then sec squared 3x tan to the power of 4 3x. If you guys have forgot about the chain rule, maybe look back at the previous videos. So now this is going to be 15 sec squared 3x tan to the power of 4 3x. And now we go back comparing our differentiated value along with the original integral. As you can see, we have to try and make a 15 into 2. So therefore, I need to multiply this by 2 over 15, meaning that I multiply this by 2 over 15 as well. And we know our answer is just going to be the y value here. So it's going to be 2 over 15 tan to the power of 5 3x plus the c, like this. So the process itself is quite simple. It's just making sure that you identify that it is the reverse chain rule we should be using. Okay, let's just try another question. So let's say I want to integrate 2x times by x squared plus 3 to the power of a half. This is still the reverse chain rule because if we have to differentiate x squared plus 3, we get 2x, right? So this would be our function and this will be the derivative of that function. So therefore we have to say let y equal to the function which was x squared plus 3, and then we add 1 to the power, so it's now 3 over 2. We now differentiate it, dy by dx will give us 2x times by 3 over 2 times by x squared plus 3 to the power of a half. Right, so this is going to be 3x x squared plus 3 to the power of a half. So we now compare the derivative with the original integral. We're trying to make a 3 into a 2, so we have to multiply this by 2 over 3, meaning we multiply this by 2 over 3 as well. And we know the answer is going to be our y value here, right? So this is going to be 2 over 3 x squared plus 3 to the power of 3 over 2 plus c, like this. Okay, so this is what we do for the reverse chain rule. Right, as we said in the very beginning, we have to try and identify this kind of pattern first, right? There's actually another pattern which you should also be identifying or just being aware of, and that is if I have it in the form the derivative divided by the original function, like this. Okay, so there's two patterns you should be identifying for reverse chain rule. The original one where it's multiplying, and the second one where there's when we're dividing. Things to note is this is not raised to a power of n, okay, it's just the function on its own. If this is the case, then the answer is going to be some k value times ln f of x plus c, like so. So we can show this using a example. Let's say I want to integrate cos 2x over sine 2x. We know that if we differentiate sine, we get cos, so we have its derivative over its function. So therefore, like before, I have to say let y equal to something. And in this case, we say let y equal to ln, this bottom denominator part, the function. So ln sine 2x. But like before, after we've done that, we now differentiate it. So we know differentiating ln terms, we get a fraction straight away, where sine 2x will go to the numerator. The derivative of that, which is 2 cos 2x, will go to the numerator, sorry. And therefore, we get this. We now compare this one and this one again, like before, and we have to try and make them the same. We have no 2, so I have to multiply this by 1 over 2 and multiply this by 1 over 2. So we know that the final answer is going to be our y term here. So it's going to be 1 over 2 ln sine 2x plus c, like this. So this is still the reverse chain rule, it's just a different form that we should be aware of. If we were to try one more, let's just say we have integrating e to the 2x over 2e to the 2x plus 4, like this. We know that if we differentiate e to the 2x, we get 2e to the 2x, right? So we get an e to the 2x on the top, so that means we can use the reverse chain rule. So we let y equal to ln, the denominator, sorry, so 2e to 2x plus 4. We now differentiate that. So we have 2e to 2x on the denominator. The derivative of this, which will give us 4e to 2x on the numerator. And then we compare here and here again. You can see that we need to get rid of this 4, so I multiply by 1 over 4, multiply this by 1 over 4. So the final answer would just be 1 over 4 ln 2e to 2x plus 4 plus c, like this. Okay, so that's the reverse chain rule and what you should be aware of. Certain things that you should be, or certain mistakes that students do make is, let's say I'm going to do the same example as this one here, the one we just did here. So I'm going to say integrating cos 2x, and then we're going to have sine squared 2x, like this. So a common mistake that students do make is saying, oh look, I have its derivative and I have its function as like a fraction. So I'm going to say let y equal to ln sine 2x, like this. This is not the case because we have this power of 2 here. Okay, so technically the ln term, or this example here, as I said before, only works when there's no power. It has to be just a function on its own on the bottom. You can see here that there is a power on the bottom, so it can't be an ln term. Instead, what we're going to do now is I'm going to rewrite this as saying cos 2x multiplied by sine to the power of minus 2x, like this. Writing in this term actually now converts or changes the form into the original the first form we were looking at before, where we have the derivative with its function and raised to a certain power of n. So in this case now, looking at in this form, we now have to let y equal to sine 2x to the power of -1, where we add 1 to the power of the function, right? And then we go about doing our derivative, -1, 2, cos 2x, sine -2, 2x. And then I compare it, and you can see that I have a -2, so to multiply this by -1/2, multiply this by 1/2. So the answer for here would give you -1/2 sine 2x to the power of -1 like this plus c. So just because it's a fraction doesn't necessarily mean that we change this into the ln form when we integrate it. You have to be very careful of what the power is going to be. So with this method, we can actually get to integrate 4 other trig terms, which are tan, cot, cosec, and sec. These are actually in your formula booklet, so you don't have to memorize them, but you do know how they were made, okay? How they were produced. So let's start off with the tan. So I'm trying to integrate tan x. So I'm going to rewrite tan as sine x over cos x. The reason why I do this is because now I have the function cos x with its derivative sine x above it. So therefore, I can use the reverse chain rule by saying let y equal to, because there's no power on the bottom, it's going to be an ln term this time, right? So ln cos x. We now differentiate that dy by dx, which will give us cos x on the denominator, and then negative sine x on the numerator. And we compare it, so it has a negative, right? So we need to multiply this by -1. So the integral of tan x will just be negative ln cos x. And we can, ln is a log term, or we can use one of the rules. I say ln cos x to the power of -1, which is just 1 over cos, which will give us ln sec x plus c. So that's where it comes from. Maybe if you guys have a chance, you guys can practice proving the rest of the three, the cot x, cosec, and the sec x. It's the same method as this tan x as we just did before. It's just splitting them up into something over something and letting y equal to ln some function. Okay, so to round this video off, let's just practice a couple more questions, some more difficult questions. So starting off with the first one, trying to integrate cosec squared 2x cot 2x. This is another question example which is kind of tricky and which can confuse students a bit, because you'd imagine, well, if I differentiate cosec, I get cosec cot, right? So our function would be cosec 2x, right? So I can say it's equal to cosec, let y equal to cosec 2x, and then we raise it to a power, one more power, so it's a power of 3, right? So now I differentiate it, so that will be 3 times 2 times cosec x, cosec 2x cot 2x, and then multiply by cosec squared 2x like this. But what we should realize is we actually get cosec, there's 2, that's 1, so actually 3 cosec 2x's cot 2x. So as you can see, we went to get cosec squared 2x, but we got a cosec cubed 2x. So this is a very it's an example of a question which is kind of throw you off a bit. So initially what our y should have been was a cosec 2x just squared. So the same power as the original question, because when we integrate or differentiate cosec, we get cosec cot, right? We still remain with a cosec. So in this case, dy by dx, that would give us 2 times 2 cosec 2x cot 2x, and then a cosec 2x at the end. So now it will be 4 cosec squared 2x cot 2x, and now you can see the difference is, well, there's a 4, I need to get this 1 over 4 times this by 1 over 4, so the answer will be 1 over 4 cosec squared 2x plus c, like so. Right, let's try the second one. So let's say with integrating cos x e to the sin x dx. This is still the reverse chain rule, but if I was to differentiate e, right, or exponential terms, the function, the derivative of that comes to the front. So in this case, we're going to say let y equal to just e to the sin x. If I differentiate this, I get cos x e to the sine x. And as you can see, they're the same. So this is just actually the integral of this is just e to the sine x plus c. I'm going to skip the third one because we've done a similar example before. So let's try the fourth one. So integrating 2x plus 1 over the root of x squared plus x plus 5, like this. So I can rewrite this as, notice this is not going to be the ln 1 because it's actually in the denominator we have a root to the power, a root, right, which is the power of a half. So therefore it's not going to be ln, but it's actually going to be, if I was to rewrite it as 2x plus 1 x squared plus x plus 5 to the power of negative a half, then it's going to be the first form we were looking at. So we're going to say let y equal to x squared plus x plus 5 to the power of positive a half, adding 1 to the power. So I differentiate this. So we get a half, we get differentiate the inside, we get 2x plus 1, and then rewrite the whole bracket, minusing 1 to the power, so negative a half. We now compare this original one with the original integral. As you can see, we have this extra half, so we need to multiply it by 2, multiplying this by 2, so this will now be 2 x squared plus x plus 5 to the power of a half plus c, like so. Okay, let's just look at the final question. So we're trying to integrate sine x cos x over cos 2x plus 3. Once again, this might seem like it's not the reverse chain rule, but what we can see is, well, if I was to differentiate cos 2x, I get 2 sine 2x, right? And sine 2x using the double angle formula is actually 2 sine x cos x. So I get this sine x cos x. So in this case, it is the reverse chain rule. And also because the power here is technically power of 1, right? It's actually going to be, our y is actually going to be a form of a ln. So it's going to be let y equal to cos 2x plus 3. So if I was to differentiate this dy by dx, it will have cos 2x plus 3 on the denominator. I now differentiate this, so I get 2 or negative 2 sine 2x, which I can now expand to give you negative 4 sine x cos x using the double angle formula over cos 2x plus 3. We now compare here and here. As you can see, we have this negative 4, so I should multiply this as negative 1 over 4, multiply this by negative 1 over 4, multiply this by negative 1 over 4. So this is going to be negative 1 over 4 ln cos 2x plus 3 plus c. So even though it doesn't seem like it's a function or derivative over its function, you still use the reverse chain rule. That's what I meant by this particular method or rule. It takes a lot of practice and just getting used to or being exposed to a wide variety of questions. Right, so that's the reverse chain rule. In the next video, we're going to be looking at how to integrate difficult trig terms and also be looking at by parts and substitution.